From our vantage point on Earth, the sun may appear like an unchanging source of light and heat in the sky. But the sun is a dynamic star, constantly changing and sending energy out into space. The science of studying the sun and its influence throughout the solar system is called heliophysics. Let's begin. Our sun is a medium-sized star with a radius of about 435,000 miles. Many stars are much larger, but the sun is far more massive than our home planet. It would take more than 330,000 Earths to match the mass of the sun, and it would take 1.3 million Earths to fill the sun's volume. Our solar system is moving with an average velocity of 450,000 miles per hour. But even at this speed, it takes about 230 million years for the sun to make one complete trip around the Milky Way. Being part of the Milky Way galaxy, the sun, taking along the whole solar system, moves in an orbital fashion around the galaxy's center of mass at an average speed of 230 kilometers per second, taking about 220 to 250 million Earth years to complete a revolution, a galactic year, having done so about 20 times since the sun's formation. The sun is 4.6 billion years old. It is about halfway through its life as a yellow dwarf star in the main sequence. The sun formed about 4.6 billion years ago in a giant, spinning cloud of gas and dust called the solar nebula. As the nebula collapsed under its own gravity, it spun faster and flattened into a disk. Most of the nebula's material was pulled toward the center to form our sun, which accounts for 99.8% of our solar system's mass. Much of the remaining material formed the planets and other objects that now orbit the sun. The rest of the leftover gas and dust was blown away by the young sun's early solar wind. Like all stars, our sun will eventually run out of energy. When it starts to die, the sun will expand into a red giant star, becoming so large that it will engulf Mercury and Venus, and possibly Earth as well. Scientists predict the sun is a little less than halfway through its lifetime and will last another 5 billion years or so before it becomes a white dwarf. The sun is a huge ball of hydrogen and helium held together by its own gravity. The sun has several regions. The interior regions include the core, which is the hottest part of the sun. Nuclear reactions here where hydrogen is fused to form helium power the sun's heat and light. Temperatures top 15 million degrees Celsius, and it's about 86,000 miles thick. When energy from the core is carried outward by radiation. This radiation bounces around the radiative zone, taking about 170,000 years to get from the core to the top of the convection zone. Moving outward in the convection zone, the temperature drops below 2 million degrees Celsius. Here, large bubbles of hot plasma move upward toward the photosphere, which is the layer we think of as the sun's surface. Above the photosphere is the chromosphere, the transition zone, and the corona. It is simply the thin layer where the chromosphere rapidly heats and becomes the corona. The photosphere, chromosphere, and corona are all part of the sun's atmosphere. The sun generates magnetic fields that extend out into space to form the interplanetary magnetic field, the magnetic field that pervades our solar system. The field is carried through the solar system by the solar wind, a stream of electrically charged gas blowing outward from the sun in all directions. The sun generates magnetic fields that extend out into space to form the interplanetary magnetic field. The field is carried through the solar system by the solar wind, a stream of electrically charged gas blowing outward from the sun in all directions. The sun emits a constant stream of particles called the solar wind. When the solar wind collides with atoms of oxygen and nitrogen from the Earth's atmosphere, it can cause beautiful flashes of colorful light in the night sky, known as auroras. The height of the sun's activity cycle, known as solar maximum, is a time of greatly increased solar storm activity. Sunspots, eruptions called solar flares, and coronal mass ejections are common at solar maximum. Sometimes gases on the sun's surface erupt, shooting far out into space. These are called solar flares. They can interfere with satellites, meaning our phones, sat-nav, and television might not work.